The red planet has become something of an enigma, a mysterious world shimmering in the night sky with its iconic reddish glow. Mars, our planetary neighbor, is an ancient and lonely place, its surface carrying the stories of a time when it was far more familiar than the barren wasteland we see today. Now it lies dead and silent, but humanity stands on the edge of a remarkable breakthrough. As Earth enters uncharted territory, our civilization is beginning to look upward, beyond the blue door, toward the red one, and imagining Mars as our next home. But this is a world that does not welcome visitors. It is harsh and unforgiving, a dry, windswept planet of endless deserts and towering mountains. Yet beneath its scarred and dusty shell lie secrets of a lost oasis, a world that once resembled our own long before life had taken hold on Earth. Mars, the fourth planet from the Sun and the outermost of the rocky terrestrial bodies, is only half the size of Earth and just a tenth as massive. It is the second smallest world in our solar system, but what it lacks in size, it makes up for in geological wonders, mightier mountains, deeper canyons, and a landscape far older than anything on Earth. Humans have gazed at Mars since antiquity. It is the second brightest object in the night sky after Venus, shining even brighter when the two planets come closer every few years. Its striking red color, reminiscent of blood, earned it the name of the Roman god of war. The Sumerians, over 5,000 years ago, viewed it as a celestial deity. Ancient Egyptians recognized its unusual backward motion across the heavens, puzzling over its retrograde movement. Our perception remained limited until the 19th century when telescopes became powerful enough to reveal surface details. In 1877, Giovanni Schiaparelli mapped Mars and noted long channels he believed held flowing water. Combined with earlier observations of shifting dark regions on the planet, many scientists concluded that Mars was alive, with vegetation and watercourses much like Earth. The illusion persisted until better instruments revealed the truth. These channels were optical illusions, yet the myth of Martians endured. Humanity's curiosity only grew, leading to the first missions to the red planet. Mars became the most explored world beyond Earth. In 1964, NASA's Mariner 4 captured the first close-up images of its surface, shattering the fantasy of a vibrant planet. Mariner 9 later revealed that the supposed seasonal vegetation was nothing more than dust storms sweeping across a lifeless world. The Viking landers delivered the first images from the surface itself, showing rocky plains under a dusty orange sky. Over the following decades, orbiters like Mars Global Surveyor and rovers like Sojourner and Curiosity deepened our understanding, revealing key details about its soil, minerals, and ancient past. Today we have a constant presence around Mars, with multiple spacecraft orbiting the planet and one active rover on its surface. These missions collectively point to a stunning revelation: Mars was once warm and wet. Its valleys, basins, and channels bear the unmistakable signatures of flowing liquid water. It may have had lakes, rivers, and vast oceans covering about a fifth of its surface. What remains now is a frozen desert world that has not seen geological activity for millions of years. Iron-rich minerals in the dust have oxidized over time, giving the soil its rusty red hue and tinting the sky a hazy pink. Dust storms, some swallowing the entire planet, continue to scour the landscape. Mars is an extreme world. Temperatures swing from 20 degrees Celsius at the equator to minus 153 degrees Celsius at the poles. Its thin atmosphere, mostly carbon dioxide, barely shields the surface from radiation or retains heat. Seasons last much longer than on Earth due to its 687-day orbit. Mars is split between volcanic highlands and water-carved basins. The soil contains trace amounts of water, and beneath the surface lie frozen reservoirs and ancient ice sheets. The planet's crust is one solid piece, unlike Earth's shifting plates. Its ancient volcanism produced immense features like Tharsis, a massive plateau crowned with enormous volcanoes, including Olympus Mons, the largest volcano in the entire solar system, standing 3 times taller than Everest. Ancient eruptions may have pierced ice sheets, unleashing floods that carved deep valleys and colossal waterfalls. Mars also hosts the Mariner Valley, a gigantic canyon system stretching over 4,500 kilometers, wider than the United States and several times deeper than the Grand Canyon. The scale of these features hints at a once active world. Mars' 2 tiny moons, Phobos and Deimos, are likely captured asteroids. Phobos, the larger one, is slowly spiraling inward, destined to either crash into Mars or break apart into a ring. Deimos drifts slowly outward toward eventual escape. Everywhere we look, Mars shows evidence of ancient water. The Iridania Basin, once a primordial ocean, contains minerals formed by hydrothermal vents, similar to those where life may have emerged on Earth. It is tempting to imagine that simple microbial life once existed on Mars, but if it did, it likely disappeared billions of years ago. Mars' transformation into a frozen desert stems from its size. It formed in a region of the solar system where Jupiter swept away much of the available material, leaving Mars smaller and less massive than Earth. This meant its gravity could not hold onto its atmosphere as effectively. During the violent early years of the solar system, asteroid impacts stripped away much of its air. As its interior cooled, Mars lost its magnetic field, leaving the atmosphere unprotected from the solar wind. Over billions of years, particles from the Sun slowly blew Mars' atmosphere into space. Without enough air, liquid water evaporated or froze, and the planet plunged into eternal cold. Despite its desolate present, Mars remains central to humanity's future. NASA's Perseverance rover searches for fossilized signs of ancient life, but true progress will come only when humans set foot on the surface. SpaceX, led by Elon Musk, aims to send cargo and eventually people to Mars using the powerful Starship rocket. The vision is bold, a self-sustaining city on another world, powered by solar energy and fueled by resources made on Mars. But enormous challenges lie ahead: radiation, low gravity, long journeys, and the risks of launching from a planet with no infrastructure. Still, the dream persists. For Mars to become a true second home, we would have to recreate the environment it lost. Terraforming would involve warming the planet, thickening its atmosphere, melting its ice, and introducing vegetation. Super greenhouse gases could help jumpstart the warming process. As the atmosphere thickens, heat would build, water would flow, and eventually rain might fall again. Hardy organisms like moss and algae could produce oxygen, turning bare rock into fertile soil. Over centuries, pine forests could grow, transforming the red planet into a living world once more. These ideas sit far in the future, but they inspire hope, a hope that humanity might one day thrive beyond Earth. Mars may have lost its life-supporting environment long ago, but perhaps its greatest chapter is still ahead. If we succeed, we will become an interplanetary species, securing our future among the stars. Mars was once alive with oceans and volcanic fire. Now it waits, dusty and silent, for us to write the next chapter of its story. And maybe, just maybe, its best days are still yet to come.